As we mentioned in the introduction to carbohydrates, the periodic table hides some useful secrets. This column headed by helium has no great urge to make bonds with other atoms. The column to its left wants to make one bond. The second column to its left wants to make 2 bonds. Third column atoms want to make 3 bonds, and so on. Remembering this information, let's make a fatty acid molecule. This carbon atom wants to make 4 bonds. So let's give it a double bond with oxygen. And let's give it a single bond to an OH molecule. That's a total of 3 bonds for the carbon. It still wants another. So let's give it another carbon for its 4th bond. But now we have the need for 3 more bonds for the new carbon. Let's give it 2 hydrogens and another carbon. Now this new carbon needs 3 more bonds, so we give it 2 hydrogens and another carbon. We could keep going, making a chain of carbons, with each carbon having 2 side bonds to hydrogen, but let's end it by adding 3 hydrogen atoms, like this. This molecule is a molecule of butyric acid. It is the shortest chain fatty acid, containing only 4 carbon atoms. Here is another fatty acid. It is a molecule of stearic acid. It contains 18 carbon atoms. Notice that all the middle carbons in the chain contain bonds to 2 hydrogen atoms. This configuration contains the maximum number of hydrogen atoms possible. So this molecule is termed saturated, as in saturated fat. An alternate possibility for an 18-carbon fatty acid is this one. It is a molecule of oleic acid. And notice there is a double bond between carbons 9 and 10. So each of those carbons have only one bond available for the side hydrogen. Since there's a possibility to add hydrogens to this configuration, we say that it is unsaturated. And since there is only one carbon double bond, we say that it is monounsaturated. If there were 2 or more, we would say that it is polyunsaturated. Also notice that the carbon double bond causes a kink in the carbon chain. All naturally occurring fatty acids with a double bond have a kink in their shape at the location of the double bond. But it is possible to manufacture fatty acids that are transformed in shape to do away with that kink. These trans fats are more stable, so food manufacturers prefer them. But without the kink, they physically pack together easily and tend to clog arteries as a result. Adding hydrogen to replace carbon double bonds is called hydrogenation. Now let's build a fat molecule from these fatty acid building blocks. We begin with a molecule of glycerol, which will form the backbone of the molecule and hold the fatty acids in place. These hydrogen atoms in the glycerol then combine with OH molecules at the end of the fatty acid chains to form 3 molecules of water, while the rest of the fatty acid chains join to the now exposed oxygen atoms. 3 fatty acids joined to the glycerin form a molecule of triglycerides. And although triglycerides can become hazardous to your health if the level of them in your bloodstream gets unnaturally high, they play an important role in metabolism as energy sources and transporters of dietary fat.